Hello guys, so in this video I want to do a different kind of problem involving trigonometric, or actually integration by trigonometric substitution. So this is for those of you that are in Cal 1 or Cal 2, actually Cal 2, unless you have a professor in Cal 1 that does this, but it's mostly learned in Cal 2. So sorry guys, so let's go ahead and get started. Give me 1 second, everybody. Okay, so let's look at this problem here. So here we have this problem, and just so you guys know, I did work this out beforehand, because it is a pretty lengthy problem. So I have my notes here. Let's just kind of did it on computer paper before actually doing it on here. So we have the integral of the square root of 9 minus x squared all over x squared dx. And I'm going to go ahead and rewrite it. So we have the integral of the square root of 9 minus x squared all over x squared dx. And also, if I do still sound a little bit sick, guys, I'm still recovering, so I do apologize. But let's go ahead and do this. So the rule goes like this. There's a certain rule that if, in the square root, basically, and I'm going to write this rule down, if given the square root of, let's say, a squared minus u squared minus u squared, then u, let's say, then u is equal to, and we're going to say a sine of theta. So this is a rule that we use for trigonometric substitution. And before I actually kind of substitute everything in, I also want to say that du, the derivative of u, so and let's do du is going to be equal to a cosine theta d theta. So it's going to be a cosine theta d theta, okay? And so here we're basically, this is what we have right here, right? And again, I'm going to rewrite it. So I can rewrite the integral of the square root of 9 minus x squared over x squared as the following, right? So we can go ahead and say the following. This is equal to the square root of, it's going to be, so if I go ahead and say 3 squared, I can say 3 squared minus, and I can say x squared over, and then I know that on the bottom we just have x squared, so we have something along the lines of this, right? Let me make sure it's recording well. Okay. So now what we're gonna do is, so now we have something like this, and like I said, u is x, so I know that u is equal to x, and I know that a is equal to 3, so because we basically substituted, a squared was 9, and so a is 3, x is equal to u. But we want to use this formula here now to actually substitute our x in. So we're going to actually put x in here. So x, because u is x, we're just going to say x. put that in place of this here, and we're going to say this is equal to, and a we said was 3, so it's going to be 3 sine of theta. And I know that if I'm doing x, I need to find dx. So dx, the derivative of x, is going to be 3, and the derivative of sine theta is cosine theta, d theta. So we should know that from like Cal 1. And then finally, we're going to try to solve for, so we're basically going to substitute. So we now have dx equals 3 cosine of theta d theta. So we're going to substitute in this for this. So now this actually, and we're going to substitute the x equals 3 sine theta part. We're going to substitute that in for whatever's inside x in that parentheses. So let's rewrite here our stuff and without color coding it really. So we had x equals 3 sine theta, right? And then we also had dx is 3 cosine theta d theta. So that's basically this stuff. And so what I'm going to do is, I know I have, this is, and we have the integral. And so we're going to do, and this is dx, and we're going to make this equal to the integral. And we're going to do the square root. 3 squared is 9, so we had 9 minus, and in place for x, we're going to put, so we have 9 minus x squared over x squared dx, but this is going to be in place for x right here. Right here, we're going to go ahead and put, that 3 sine theta in. So give me a second, guys. Okay, so this is what we have here. Let me actually full screen again. And if I'm going a little slow with this, guys, I do apologize. I'm really trying to explain this the best way I can. I don't like to speed things up a lot. So again, we're going to put in 3 sine theta for x. So we have the square root, the integral of 9 minus, and it's going to be 3 sine of theta. So 3 sine of theta squared. So that's basically this over here. That's what we put in for x. And then let me actually move. And then over. And then we had, again, the same thing. We're going to put 3 sine of theta squared. So it's basically this again, but squared. So you can clearly see that kind of what I'm plugging in here. And dx, like we said, was this here. So we're going to put times 3 cosine theta d theta. So that's in green, right? So everything kind of goes, we're basically converting everything in terms of theta. So now we have, this is equal to the integral of the square root of 9 minus 9 sine squared of theta, because 3 sine of theta squared is really 3 squared. It's really 3 squared sine of theta squared, right? So it's going to be 9 sine squared of theta. I just want to make that very clear. So that's what goes in for that. And then, so like I said, let me just, again, making sure everything is aligned. This is what I put in for that. And on the bottom, I'm going to put the same thing, 9 sine squared of theta, right? So that's what we have on the bottom. And then times 3 cosine of theta d theta, okay? So now we have to just simplify this. We know this is kind of like trigonometric identities, so we need to factor out a 9 from here. So 9 times 1 minus sine squared of theta over 9 sine squared of theta times 3 cosine of theta d theta. So then what I do now is I know that one of my trig identities is going to be that cosine squared of theta equals 1 minus sine squared of theta, and that's just manipulation of the Pythagorean identity. So this stuff is going to go in for this. So now we're going to have the following. The integral of the square root of 9, and we're going to put cosine squared of theta, and then over 9 sine squared of theta times 3 cosine of theta d theta. And obviously, because there's a 9 and times cosine squared theta, we can separate those two as two different radicals. So this becomes the integral of the square root of 9 times the square root of sine squared theta over 9 sine. I'm sorry. Oh my, I keep making that mistake, guys. So sorry about that. Cosine squared theta over 9 sine squared theta times 3 cosine theta d theta. And so we know that the square root of 9 is 3, so we got the integral of 3, right? So this just becomes 3, and then integral of cosine squared theta, well, we know that it's going to be the absolute value, but we don't really need that in this case. At least I don't think so. So we're just going to put it as cosine. Oh, God. Sorry, guys. 1 second. Okay, sorry, guys. So let's go back. So, we're going to put this stuff here, this whole thing, as just cosine theta over, and it's going to be 9 sine squared theta times 3 cosine theta d theta. So now we're just going to multiply these two things on top here. So really that whole part becomes, it's going to be the integral of 9 cosine squared theta over 9 sine squared theta d theta. And from trig identities, we know that cotangent squared theta, we can call it cosine squared theta over sine squared theta. This is a trig identity, right? So then we know that the 9's cancel here, and so we have the integral of cotangent squared theta d theta. Okay. Now we want to go ahead and find the integral for that, and luckily we know the integral for that specific part. And the integral, let's just do the actual integral. This is an integral that they give you. The integral of cotangent squared of u du is equal to negative u. It's going to be negative u minus cotangent of u plus c. So we know that this is going to be negative theta minus cotangent of theta plus our constant of integration c. This is what originally it would be if the whole thing was in trigonometric form. However, that is not how this looks. We need to do it. We need to turn it back into actual algebraic form. So to do that, we know that in the very beginning of this problem, we had x equals 3 sine theta. I can manipulate that and say, that if I have the following, so if I have x equals 3 sine theta, I can go ahead and say I can divide it by 3 on both sides and say that sine of theta is x over 3. So now using right triangle trigonometry, if I actually use right triangle trigonometry, so if I make a right triangle, it doesn't look like a right triangle, but let's see. Something like this. And I go ahead and say that here is theta. I know that sine of theta is x over 3. That's going to be opposite over hypotenuse. So we always have to remember the different, the different parts of, whenever we have right triangle trigonometry, we need to remember what sine of theta is and in terms of the triangles. So, another thing is that, so for example, we had negative theta, and right now we don't have that. So to find theta, we need to do the sine inverse of this whole thing. So that means that sine inverse of sine theta, that cancels out. So theta is equal to sine inverse of x over 3. And this is what would go for this, but it's negative, right? So I know I have that part down, and now I need to find my other part here for b, since I only have sine of theta equals x over 3. I need to find b. Using Pythagorean theorem, I know it's x squared plus b squared equals 3 squared. If y'all don't know what Pythagorean theorem is, I'm just going to quickly tell y'all. So it's a, if I have a, b, and c, I know that a squared plus b squared equals c squared, or c equals the square root of a squared plus b squared. That's Pythagorean theorem. Okay, so we know that if we kind of work this out, we have x squared plus b squared is equal to 9, because 3 squared is 9, right? So then we will go ahead and subtract x squared on both sides. That'll give us b squared equals 9 minus x squared, but we're looking for b, not b squared, so take the square root, get b is equal to the square root of 9 minus x squared. So now we know this is equal to the square root of 9 minus x squared. Okay, so we had theta. Now we need to find cotangent theta. So cotangent theta is actually going to be adjacent over opposite. This is my adjacent side. This is my opposite side. So cotangent theta here is going to be the square root of 9 minus x squared over x. So I know that's cotangent theta. So really, this stuff here, cotangent theta, is equal to this. That's what would go for right here. So now putting that all together, we know that this just becomes the following. I have the integral of cotangent squared theta d theta is equal to negative theta minus cotangent of theta plus c. So I said negative theta, so it's going to be negative sine inverse of x over 3 minus cotangent theta. Cotangent theta is the square root of 9 minus x squared over x plus my constant of integration c. And this is actually what's equal to the integral of the square root of 9 minus x squared all over x squared dx. And this, guys, is the final answer to this problem. So it is a very lengthy problem, and I do apologize if it took me like nearly 20 minutes to do this. But I really wanted to make sure that we understand how this works. And so with that being said, guys, if anybody has any questions about this, please let me know. And also please like, comment, and or subscribe. and I will see you guys in the next video. Bye, guys.